All right, in this video we're going to take a look at how we can solve logarithmic equations using our properties of logarithms that we've seen before here. We know with a logarithm, if we have the product of two terms inside the logarithm, we can write that as the sum of two logs. If we have the quotient of two terms inside of a logarithm, we can write that as the difference of two different logarithms. If we have an exponent inside a logarithm, well, we can drop that out in front. This c can be written out in front here. All right? So using those properties, let's see how we can solve some logarithmic equations. And so before we get to some equations, let's work with these properties a bit here. Let's assume that we've got x and y are positive here. That's important for our domain. And here we want to write this as a sum of logarithms with no exponents. Okay, so let's break it apart using our properties. So we have the log of 3x squared all over y. First thing we notice is we got that quotient. We got this division going on. So we've got to use our quotient rule. If we're dividing it inside the logarithm, we can write that as a difference. So we're going to rewrite this as log of the top part, 3x squared, minus the log of y. Well, this term's great because it's just log of y, not log-e, log of y there. And here we have, we got some more stuff going on inside here. It might help if we put some parentheses around to show that that's all inside the logarithm. So we got to break this up. We have 3 times x squared. Well, that's a product. So let's use our product rule. These two things are multiplied inside, so we can break it up with a sum. So this becomes the log of 3 plus the log of x squared. And we'll copy down the log of y. All right. Now we're getting close. Log of 3, that's about as broken down as it gets. Log of y is fine. But we've got this x squared. Well, let's take that 2 and drop it down. And so we can rewrite it one more time as log of 3 plus 2 log of x minus the log of y. Now obviously the ones with the x and the y we can't do anything with. You might think that maybe we should plug this into our calculator, but we want to leave it. It's an irrational number, the log of 3. Let's leave it as it is. So now let's go to our next one. Now we have an expression here, and instead of breaking it apart, we want to put it all together using our properties. So let's try that out. Let's take our 3 natural log of n. Remember, ln means natural log, or that's log base e. So this 3 outside can be put up in the exponent. That's using the power rule here. If we have this c out here, we can put it up on the p, and we can rewrite it in this form. So we're going to use that rule backwards. And so we can write the natural log of 2 to the third. That's the first term. The second term, well, this 2 can go up as an exponent, and the 1/2 is going to go up also for the last one. So that's going to be natural log of 4 to the second, natural log of 16 to the 1/2. And since we have no variables here, these are numbers that we can figure out. We know what 2 to the third is. 2 to the third is 8. So this is natural log of 8. We know that natural log, or 4 to the second power, is 16. And we know that the 1/2 power here is the square root of 16. Square root of 16 is 4. Now we've got 2 logs being subtracted here. Well, looking up at our quotient rule, these 2 logs can be put together as 1 log with division. So these 2 here become the natural log of 8 over 16. And the 8 over 16 is inside the logarithm. And we know that that's a half. This addition here is going to become multiplication. So we're adding 2 logs. We can write that as the log of their product. So let's go ahead and do that. We've got natural log of, well, let's write 1/2 as 8/16 times the 4. And that's just going to give us the natural log of 2. And so all of this original expression becomes the natural log of 2. So in some cases, we want to squeeze logarithms together to make one simpler logarithm. In some cases, we want to break it apart. So we need to be able to do both there. Now let's see how we can use these techniques when we're solving equations. When we're solving logarithmic equations, we have two basic techniques or methods. And the first one here is we want to move all logarithms to one side and then simplify to make one logarithm and then convert to exponent form. So we're going to start out with a real simple one, and we have the logarithm base 3, log base 3 of x plus 1 equals 4. Well, this is all ready to go. So all we need to do here is go ahead and take the base, which is the 3, and we're going to write it in exponential form. And so this means 3 to the 4th power is equal to x plus 1. Well, we know what 3 to the 4th power is. It is 81. And we subtract 1, x is 80. We always want to test it out now. Let's take 80 and plug it back in and see if that works. Or specifically, we want to see if it is in the domain. Is it okay to plug 80 in here? Yeah, we get 80 plus 1 is a positive. Remember that we always have to put positive numbers inside logarithms. If this comes out to be a negative number, then this x doesn't work. And it is possible to have logarithmic equations with no solution. So watch out for that. This is good. This gives us a positive answer. Well, that was too easy of a problem, so let's come up with a little similar one that will strain our brain a little bit more or challenge us a little bit more. So we got log base 3 of x equals 4 minus log base 3 of 5. Similar, but a little different here. So what we need to do, going to use this technique number 1 up above. We're going to add the log base 3 of 5 to both sides, and that will give us this, the log base 3 of x plus log base 3 of 5, which is just some number. And we want to avoid decimals. We could go to our calculator and get some decimal number here, but that will just get messy. We want to keep it exact. Okay? And we have a property that tells us if we're adding two logarithms, well, we can write that as the log of a product. So this is log base 3 of 5 times x, or 5x. Well, that's nice. And so here we have a single log, and that's what we want. We want to simplify to make one logarithm. We got that. Now let's take this exponent here, or this base, sorry about that, and let's rewrite it in exponential form. So 5x equals 3 to the 4th, and we know that means 5x is 81. And we divide both sides by 5, and we get 81/5. There's the exact answer. All right? And so that's using technique 1 there. Technique 2, or method 2 if you want. Method 2, we're going to take and we're going to write both sides of an equation as one logarithm with the same base, and then we convert to exponential form and solve. So here we have logarithms on both sides. They're all base 10 logarithms. That's good. So let's go ahead and do some work with them. Let's simplify this. Let's take the 2 and put it up, take the 3 and put it up, like we did in the other examples a little bit ago. This is log of x squared plus the log of 2 cubed, which we know is 8. And we'll leave the log of 16 alone. The left side can become a little bit, this is 8. We'll do that here in a second. But we're adding logs, so let's write that as a product. So I'm going to do 2 for 1 here. So we're going to have the log of this 8 times the x squared. So that's 8 times x squared, or 8x squared, equals the log of 16. Well, we notice here we got the same base 10, which is invisible, base 10. So the log of 8x squared equals 16. Well, that means that these two things must be equal. You can also think of it this way. We're going to raise both of them to the 10th power. And this is saying this is the power that we put on 10 to get 8x squared. Well, so So what this gives us, so when we take that mystery power and put it on 10, it just gives us 8x squared. So basically 8x squared, the thing in the parentheses has to equal 16. We divide by 8, and we get 2. We square root, and we get plus minus the square root of 2. And that seems to be our answer, but now we've got to plug it back in. So as we look back up at the original equation, is it okay to put negative square root of 2 in here? And no, it's not. You cannot put a negative number inside of a logarithm. The domain of a logarithm function is positive values for log of x, and so we can only use the positives. We have to throw away, we call it an extraneous solution. It looks like a solution, but it's not. So the only answer is x equals the positive square root of 2. That is our one solution, and we have solved the equation. So that's our method 2. Okay, so if you can write both sides as a logarithm like this, we can just take the inside of this one equals the inside of that one and go from there. If we can get all logarithms to one side nicely and work from there, that's another way to go. So that's how we solve our logarithmic equations using our properties of logarithms. So good luck, try that out, and you'll do well.